your primary knowledge of your school general physics, that is Newton's second law of motion, force is equal to mass multiplied by acceleration or rate of change of linear momentum. Now we can express it in some other form also, and that we are talking about integral f dx is equal to integral half m dv, half mv dv. Okay, and popularly it is known as, you can remember,
Sir, work energy theory.
work energy, that is work done from position 1 to position 2, that is change in kinetic energy from position 1 to position 2, that is the final kinetic energy minus initial kinetic energy, that is equal to the total work done. Now, can you remember comparison to the previous method, that is F is equal to ma, then find the acceleration, then integrate it to get the velocity, displacement, etc. Do you get any advantage in this work energy principle?
Sir, we can get the velocity expression, so we don't need to integrate like for acceleration. Only one time integrate, we can get displacement.
So directly we can connect to the velocity. Okay, then anything more?
Sir, it can take account of non-conservative forces also.
Anything?
Your screen is not shared, I think.
In that work energy equation, those forces are not involved which do not work. Okay. So it is something like, suppose we have that very simple example. One object was resting on this.
Sir.
Yes.
Sir, someone else is sharing the screen. Vipin Kumar Sharma.
तो उनको बोलिए ना बंद करने के लिए.
विपिन अनशेयर कर दो यार, दिखाई नहीं दे रहा है कुछ.
क्या भाई?
Stop the
स्क्रीन शेयर है तुम्हारा.
You have shared your screen actually.
उसको किक कर दिया किसी ने.
अभी?
Yes sir, now it is.
Yes sir, visible.
Now what about its free body diagram? Normally the self weight, the normal reaction, if there is any force acting maybe at any angle theta, then with the application of this inclined force P at an angle theta, there will be a tendency of movement in this direction. If it is not moving, it is the problem of statics. Then some friction will be there. It is the reaction multiplied by the coefficient of friction. If it is not moving, then it's like that, mu static. If it is moving, then yeah,
P cos theta is equal to mu r.
Mu k, and this P cos theta minus F the direction of movement, we have that mass multiplied by acceleration. So we determine the acceleration that way. But one thing is there, if the object is on an inclined plane, In that case, suppose the force is again at an angle theta with this inclined plane relative to that, having self weight W, there will be a tendency of movement in this direction if the force P can overpower that friction. Reaction, if it is moving, it's like that only. Now, in the case of work done, we consider the force multiplied by displacement, or in the dot product, that is magnitude of force, magnitude of displacement, that multiplied by cosine theta. So either it is F cos theta multiplied by S or F multiplied by S cos theta. So either you resolve the displacement along the direction of the force, or you resolve the force in this direction, some F sin theta like thing, and actual movement in this direction. But whatever you consider, you will find some forces which are perpendicular to the movement. When it is moving horizontally, then W is perpendicular to that. When we consider the force component along the plane and actual movement you have considered, then this reaction is perpendicular to the direction of movement. So what about the work done by W or work done by this R? In these two cases, as well as for the second case, work done by this one and component of this P there. But individually, for the first case, when you consider the component along horizontal direction, then W multiplied by the corresponding coefficient, rather component of displacement in the direction of W, or displacement multiplied by corresponding component of W in that direction. What about that quantity? Is there any component of W along horizontal direction?
No, sir.
So we do not need to include this force in that equation. Similarly, when we consider the displacement along the inclination upward or downward, then this normal reaction, which is perpendicular to the direction of displacement, that is also not involved in that calculation of work done. So that thing is also there, that automatically some forces are not involved in that equation. Okay, and moreover, directly we can get the velocity, that is also there. We don't need to find the acceleration. Okay. Now let us think about some common example. Or sometimes you will find these expressions are written in the form of not work done is equal to kinetic energy, work done from position 1 to position 2, that is the difference in the kinetic energy for final and initial configuration. Either in that way, or sometimes we write the initial kinetic energy, that is equal to work done from changing its configuration from 1 to 2 plus sorry, bring it to the left hand side. So initial kinetic energy plus work done for changing the configuration from 1 to 2, that is the final kinetic energy. So whatever expression you find comfortable, you use that. Sometimes we have some regular practice using either this type of expression or this type of expression. So whatever way you feel comfortable, you use that. But finally, we must remember the total work done by all the forces. And of course, those forces are automatically excluded when there is no component of that force along the direction of the displacement. This kind of simple problem definitely you have experienced, that a package is projected up a 15-degree incline at A with an initial velocity of 8 meters per second, knowing that the coefficient of kinetic friction between the package and the incline is 0.12, determine the maximum distance d that the package will move up the incline. The velocity of the package as it returns to its original position. So part A is the normal type. This is usual practice, the maximum distance d that the package will move up the plane. So maximum distance d means
velocity is 0.
That is final kinetic energy
Will be
is 0.
0.
And what about initial kinetic energy?
So that 8 meter per second, half into m into.
What about the mass?
M पकड़ लेते हैं sir.
M तो दिया नहीं. Would it have been given? It will be simply half m multiplied by 8 meter per second square. It should be in kg. And what about the unit of this kinetic energy?
Sir, potential energy जो difference है d sin 15 degree. mg d sin 15 degree.
Kg meter square per second square, or in the form of kg meter per second square multiplied by meter. And somebody was telling me about that potential energy that work done against the gravity force. Okay, that same thing. Newton multiplied by the distance in meter. What about the unit? It is in joule. Okay, joule, or for bigger quantity it is in kilojoule, whatever it may be. But one more thing is there. What about the moment of a force?
So that we write Newton meter only.
That we write in Newton meter, not in that way. Okay. And a similar thing you have done Newton per meter square and Pascal. Okay. When it is some externally distributed force, then it is in Newton per meter square. But when it comes regarding internal resistance of any object against any externally applied force, and that resistance per unit area, which is offered from the materials own within, it is in the form of that. And when it is coming in the form of the liquid pressure, that is also force per unit area, that should be given in that unit of Newton per meter square, but in the form of Pascal. So similar such things are there, but for this particular situation, the energy is in joule and moment of a force in Newton meter. So first part, it is simple. For second part, the velocity of the package as it returns to its original position. Now, one thing.
Initial is 0, final we can calculate.
But one special thing is there. When it is moving up, this is the friction resistance. When it is moving down, in that case, what about the friction resistance? That is also mu k multiplied by r. So what about the work done by that friction resistance? It is fixed. Whether it is moving up, then friction is acting opposite to that. So work done for this friction force will be mu k r multiplied by that distance d max. Okay, and it is negative. And for the second case, when it is coming down, in that case also, work done by the friction force, it is displacement is opposite to the friction force, like the previous one. Here also it is minus F multiplied by d max. And for this case also, minus F multiplied by d max. Okay. So this thing acting in opposite direction, but the force due to gravity, it is not changing its direction. It's not like that when it is moving upward, weight is acting upward, and when it is moving downward, weight is acting downward, not in that way. But this force, friction resistance, it will be doing that negative work, because actual direction of displacement and the direction of the force are opposite to each other. So final velocity, initial velocity for the first case, final velocity is 0. For the second case, initial velocity is 0, so initial kinetic energy is 0. And finally, including this quantity of work done by the friction resistance, we can find it out. Perhaps you have done a similar kind of problem in your school syllabus. Now, such different varieties, including this friction resistance, including the shape of the path. Not necessarily the path will be a straight line. It may be a curved line also. So such type of things we need to consider with just little care. Now, before going to this problem, let us talk about this one. A small body has a speed, initial velocity VA is equal to 5 meters per second at point A, neglecting friction. Determine its speed VB at point B after it has risen 0.8 meter. Friction is not there. Normal reaction is there, but normal reaction is not involved in that calculation of work done, because it is perpendicular to the direction of the movement. At any location, the displacement is tangential to the path and perpendicular to this reaction. So that part is not involved. Now, what about the force due to gravity? It is mg and acting vertical downward. Now, what you can do, find out the component along the plane tangential to the plane and multiply with the displacement ds. So w sin theta multiplied by ds, w sin theta, theta is variable, w sin theta multiplied by ds, w sin theta multiplied by ds, either in that way or along the direction of the force net movement. So along the direction of the force, what is the net movement of the object when it is traveling from this position A to this position B? It is minus 0.8 meter. So either mg minus the mg multiplied by minus 0.8 meter. So if it is in Newton mg, and it is meter, so that much joule, and that will be half m VV square minus half m VA square. So initial kinetic energy plus work done from A to B, that is equal to half m VB square. Clear? Only thing, this part will be negative, and this kinetic energy, whether it is at 1 or at 2, whether it is traveling upward or traveling downward, it will always be positive, and it's a scalar quantity. Only it is having magnitude. Now this part is simplified corresponding to mg multiplied by minus 0.8. So this type of problem, not difficult, but a little care. So in this work energy equation, the work done from configuration A to configuration B, there is a difference in kinetic energy. Final kinetic energy at B minus initial kinetic energy at A. Okay. Now, in some reverse case, suppose it is traveling downward. It has been released from rest from B. Okay. Done. So what about the velocity here? Then naturally half m VA square minus half m 0 square, that is equal to work done. Now in this case, W multiplied by 0.8, it will be positive because it is in the direction of that force W. So W multiplied by that 0.8, that is equal to either half mVA square minus 0 or initial value 0 plus this. It is the final kinetic energy. Whatever way you feel it comfortable, but W, that is mg, we get cancelled. But during examination, you should not cancel this term directly on this. You write this equation again, and there you remove these terms m from both sides. Otherwise, what happens? It looks like simply striking out some portion of your answer, whatever you have written. So as if you are scratching out some text material, whatever you are, suppose you have scratched this word there. So naturally, what your examiner will feel that definitely you have done some mistake, and afterwards you understood that, and then you crossed that or you striked it out. Okay, so for your home practice, definitely you can do cancel this m and m in that way directly, normally what we do, but during examination on the answer script, you should not do it because it will create some confusion whether you have done some mistake and you strike it out, or you are cancelling these non-zero equal terms from both sides of this equation. Okay, but this thing is definitely true. It is with some initial velocity traveling upward, what will be the maximum, rather the maximum distance, that is at velocity 0, or it starts from here, and what about the velocity it reached. But only thing, there is no friction resistance. Okay, this part is very important. If friction was there, it would have been like the previous case. Now, similar such case is here. Packages are thrown down an incline at A with a velocity of 1 meter per second. The packages slide along the surface ABC to conveyor belt, which moves with a velocity of 2 meter per second. Knowing that kinetic coefficient of friction is 0.25 between the packages and the surface ABC, determine the distance D if the packages are to arrive at C with a velocity of 2 meter per second. Now, definitely you have seen for transporting some material, so this constant velocity with which this conveyor belt is moving 2 meter per second, it is fixed, and you are allowing the packages with some initial velocity 1 meter per second. Suppose from some container you have dropped this here and it is traveling through this 1 meter per second. Now during this movement under the gravity, it will reach some velocity here. Then friction is acting on this horizontal floor also for a distance of 7 meter. So it is expected that this velocity Vb will be more than 2 meter, and this horizontal part is there to resist that velocity or to restrict the velocity at 2 meter per second. Okay, and this friction will do that negative work and decrease the velocity, but we need to make that velocity Vc 2 meter per second so that there is no jerk when it is coming here. Now, definitely many of you have that experience of traveling in an aeroplane. क्या रे? किसी का एक्सपीरियंस नहीं है?
Yes, sir.
अच्छा बताना।
Yes, sir.
Yes, sir.
डरने का या शर्मिंदा होने का कोई बात नहीं है। लोग नहीं कहेंगे बेटा तेरा तो बहुत पैसा है, तू हवाई जहाज में सफर करता है। बात ऐसा नहीं। I am just talking about that conveyor belt. When you approach that counter, you need to put your luggage there, and it travels up that inclination, and it is placed on that conveyor belt, which will take it to that. So such kind of example definitely you have seen. So here is also some such simple example. Is like that. It is dropped down with initial velocity 1 meter per second along this inclination. Definitely there will be some increase in the velocity and there will be some decrease in the velocity, and that ultimately balances to this 2 meter per second, and without any jerk it is placed on the conveyor belt and it travels to the desired location. So two portions are to be considered separately. From this part to this part, in that work done portion, W is there. W multiplied by what about this distance? D sine 30. Okay, and along the direction of the self weight, it is acting. W multiplied by D sine 30. Then resistance, friction. What about that friction resistance? Normal reaction R is W cosine 30. That multiplied by mu K is the friction resistance, and this multiplied by the distance D only, because it is acting along that same plane. The direction of movement and of course direction of friction will opposite to each other. So this part contributes with this negative sign. Okay. Then for this part, what about the portion corresponding to self weight? Displacement is horizontal, self weight is vertical, so there is no contribution. Only thing, reaction that is equal to W, that multiplied by mu K, that multiplied by the distance 7 meter, and it is with here negative sign. So movement between A and B, get the value of VB. Movement between B and C, get the velocity at C, and that value is restricted. Vc is equal to 2 meter per second. It is fixed. Okay. So simple combination of these two planes, inclined and horizontal, component of self weight or component of displacement, displacement inclined or displacement horizontal, then work done by the friction, obviously it will be negative because the friction resistance is opposite to the direction of movement. And for the first case or first part from between A to B, the friction resistance, rather it depends on the normal resistance. Normal resistance is W cosine 30. For the second portion B to C, normal reaction is W only. So those things you need to consider.
Sir, is the answer 6.71 meter per?
हो सकता है. So ideas are simple. Calculation may give you little trouble if you do not concentrate on these expressions and their signs. Okay, so please have patience. These areas are one really a simple hunting ground of scoring marks. Okay, but it may be treacherous if you do not pay proper attention to this thing. Now, some other thing which includes this. Regarding this, we have discussed this kind of thing. Can you remember? Initial no deformation, some final deformation indicated by this green line, and the total work done under this graph, either in the form of integration if it is a non-linear graph, or if it is a linear, then it will be half multiplied by base of the triangle multiplied by altitude of this triangle in that similar manner. So it is one part. Other thing is the spring is initially compressed with some value, and in that case we need to consider the area under this graph from initial to the final. Okay, not starting from 0. Okay. Now, what about the problem statement? The spring is unstretched when x is equal to 0. If the body moves from the initial position x1 is equal to 100 millimeter to the final position x2 is equal to 200 millimeter, determine part A, the work done by the spring on the body. Now, what about the force offered by the spring on the body?
Kx minus kx.
Kx.
K del X means difference.
This is the direction of the force offered by the spring on the body. And what about the movement? It is opposite to that. So determine the work done by the spring on the body. It will be
Minus Kx dx. Okay.
exactly, because force applied by the spring on the body is up the plane and object is moving downward, down the plane. So it will be negative. And next part, determine the work done on the body by its weight. By its weight means
So positive, it will be
positive,
m
and
sin theta into
it
d.
is traveling downward. So that displacement multiplied by sine 20 degree, that multiplied by W, or what you can do, that W to be resolved along this 20 degree, that is W sine 20, that multiplied by D, ultimately that dot product. So regarding this part, the sign is important and you need to consider it. It is not simply we calculate from delta or X rather, from X1 to X2, this area with negative sign. And similarly, work done by the object when it is moving down on the spring, it will be positive. Now that sign and its the direction of movement, the friction, etc., all such things you need to consider very carefully. Just a little care will give you that good score there. But you need to involve all the components except where force and displacement are mutually perpendicular to each other. Now, before going further, I need to do that same important thing. Okay, is that page again visible?
Yes, sir.
Now, similar kind of thing involving friction. The unit here is in foot-pound-second system. Now that 64.4 pound crate slides down the curved path in the vertical plane. If the crate has a velocity of 3 feet per second down the incline at A and a velocity of 25 feet per second at B, compute the work. Now the notation used here is U, capital U, UF done on the crate by friction during the motion from A to B. Now what about the direction of friction? Opposite to the direction of movement. But what about the exact direction that opposite to the direction of movement?
Sir, horizontal.
Not horizontal, tangential to this path.
Yes, sir, it will.
But we do not know the slope of this path. It is varying. It is not a simple straight line slope. But one thing is sure, the kinetic energy at configuration A plus work done from A to B, it will be kinetic energy
At B.
at B. Now this thing, one is the self weight, other part is friction. Now for self weight, it will be W multiplied by 20 feet, that is the distance. Okay, but for this friction part, we can simply find it in this way. The work done due to friction,
Mu times n into dx.
it will be
mu times n.
nay.
Work due to friction and
Acha sir, we know
Minus-
the velocities and we know the work done by gravity, so we can subtract.
minus
okay, sir.
आप समझे? This part is there. Work done from A to B. This is the combination.
Sir, but one relevant point is observed, sir, here. If we calculate the work done by friction here, sir, it will come like mu k into mg into 30 that we have horizontal thing that is there. One observation comes like that.
Yes, it will be like that into 30 into dx. We
Okay.
need to take.
That also you can do. But what about this thing? Initial kinetic energy plus work done, which includes the positive work done, this negative due to friction, and that is equal to final kinetic energy. This
Yes,
final
sir.
kinetic energy is given in terms of this given velocity. It's not like that. Find out the velocity at B. Okay. If it was asked, in that case, definitely we could calculate in this way. The total friction loss when we integrate it, that coefficient of friction is fixed, then the slope that everywhere it changes, but it's a horizontal component, etc., etc. But once we have this simplified situation, initial velocity, final velocity, the total work done due to self weight, then only portion is remaining as unknown, that is the work done due to friction. Okay. So we need to think about all these given information which can be used to simplify our calculation time or possibility of making any error in that way. Okay. So similar kind of thing we can consider when it is traveling upward also. Either it will the final height, that is when velocity is 0, or the other thing.
Sir, your screen is again not visible, sir.
Now?
Yes, sir. Yes, sir.
Now this problem could be of that previous old problem type, that is, it is moving with some velocity and it reaches its max. Find this height against the friction, it is traveling up, and when it repeats this motion, repeats means it is coming back, then what will be, this was velocity when it was going in this way, then what will be the velocity with which it will travel at this floor or at B. Okay, so that similar kind of situation, only thing the work done by the friction force.
Yes, sir. Sir, that was my doubt. Like, if it is given at point B, velocity is known, it is thrown upward the incline, and at A it reaches maximum, so velocity is 0. So, but at that point we don't know the friction, how friction will be calculated, and two variables are there. H max is there, and friction work done by friction is there. So then how we'll do?
Initial velocity is known.
Yes, sir.
So that is the initial kinetic energy, KEB. Final kinetic energy is 0. That difference is total work done. One work done is W multiplied by this minus that height. Of course, this height is to be given there, or some other information should be given there. Okay, so it is not like the straightforward manner. So some more information.
So we are muted. Can we leave the class?